In number 26, we have an equation with two absolute values on either side of the equal sign. And we open this up with two equations, like in the previous problem. To open the absolute values, we say, well, the first situation is that we could have 2x minus 1 equal to 5x plus 7, and then they would both be equal in absolute value. Or maybe one is the negative of the other, so that gives us our second equation. Maybe 2x minus 1 is equal to minus 5x plus 7. Okay, so these are our two equations, and we'll just go ahead and solve. Let's say we subtract 2x from both sides, so we have minus 1 equal to 5x minus 2x, so that's 3x plus 7. And now subtract 7 from both sides, so we have 3x is equal to minus 1 minus 7, that's minus 8, or x is equal to minus 8 over 3. And here, let's first open these parentheses on the right. So here we have minus 5x minus 7. All right, now add 5x to both sides. So here we get a 7x minus 1 equal to minus 7. And add 1 to both sides, so we have 7x equal to minus 7 plus 1, that's minus 6. And now divide both sides by 7, and we have x equals to minus 6 over 7. So these are our two solutions. Question 27 has one set of absolute values equal to an expression with x, and the absolute value expression is isolated on the left-hand side. And we open up the absolute value expression pretty much the same way we did in the previous example. We say in this case either 3x minus 5 is equal to x plus 2, or 3x minus 5 is equal to minus the entire expression, x plus 2. Okay, now let's proceed to solve. Subtract x from both sides, and that gives us 2x minus 5 is equal to 2. And now add 5 to both sides, so we have 2x is equal to 7, or x is equal to 7/2. All right, here we'll open up the parentheses on the right. 3x minus 5 is equal to minus x minus 2. Let's add x to both sides. So here we have 4x minus 5 is equal to minus 2. And here we'll add 5 to both sides. So we have 4x is equal to 3. Now divide by 4. And we have two solutions, 7/2 and 3/4. In question 28, we have an equation with an absolute value that's an inequality. And first, let's isolate this absolute value on one side. So we'll subtract 1 from both sides. So we get the absolute value of 2x plus 1 is less than 13. Okay, so this is an absolute value less than a number. So that opens into the less than. The absolute value less than the number opens into a double inequality. So we put the expression in the absolute value that's in the middle of the double inequality. So we have 2x plus 1 is between 13 and minus 13. Okay, so that's what it means for the absolute value of something to be less than 13. That means it's between 13 and minus 13. Okay, now subtract 1 from 3 sides. We'll solve this like we solve a double inequality, isolating x in the middle. So here we have a 12 on the right and a minus 14. And now just divide by 2 and we're done. We have x is between minus 7 and 6. Okay, in 29 we have an inequality with an absolute value greater than a number. All right, so the absolute value of x plus 5 is greater than 15. So this translates, the absolute value greater than a number translates into two inequalities. So we have either x plus 5 is greater than 15, or x plus 5 is less than minus 15. So again, when we have the absolute value of an expression greater than a number, we get two separate inequalities, either greater than that number or less than the negative of that number. And then solve these two inequalities. So first we'll subtract 5, and we have x greater than 10. Again, or, okay, here we'll subtract 5, continue solving the right inequalities, or x less than minus 20. Okay, so that's our solution. X greater than 10 or x less than minus 20. Question 30 is similar to the previous question. We have the absolute value of an expression greater than a number. So again, this translates into two inequalities with an or in between. Either x over 2 minus 1/3 is greater than 2/3, or x over 2 minus 1/3 is less than minus 2/3. Okay, here we just have some fractions to deal with. We'll multiply both sides by the common denominator of 6 to clear out these fractions. Or actually, okay, let's just do it like that. We'll multiply by 6. Okay. So here on the right we get 2 times 2, we get 4 on the right. All right, here we're multiplying by 6 as well. Okay. So we have 6 over 1 times x over 2 minus 6 over 3. All right, so we have 3x minus 2 greater than 4, or adding 2 to both sides, 3x greater than 4 plus 2, 6. Divide both sides by 3, x greater than 2. Here, let's do the same thing. We'll multiply both sides by 6. All right. And here we get a minus 4 on the right. And on the left, we have 6 times x over 2 minus 6 over 3. Okay. (3x minus 2 less than minus 4). Add 2 to both sides, so we have 3x less than minus 4 plus 2, that's minus 2. Divide by 3, we have x less than 2/3. And we have an or in between, x greater than 2 or x less than 2. Question 31 is a distance problem, so we're going to use the distance formula. So we'll write down the square root and 2 sets of parentheses squared. And we're finding the distance between these 2 points. So we'll subtract the x coordinates in the first set of parentheses, 3 subtract minus 2, and minus 5 subtract minus 9 in the second set. Okay, so what's that equal to? Well, this is 3 plus 2, so that's 5 squared, that's 25. And here we have minus 5 plus 9, that's 4 squared is 16. So that's the square root of 41. And that's the distance. In number 32, we're going to find the midpoint of the line segment with these endpoints. So we'll use the midpoint formula. All right, so the midpoint is equal to, and what we do here is we take the average of the x values and the average of the y values. So we're going to first add up these x values. Okay, so that's 2 plus minus 4. And then in the second coordinate, we'll add these y values. So that's 5 plus 7. All right, so that comes out to, this is minus 2 over 2, which is a minus 1. And here we have 12 over 2, that's 6. Okay, so the midpoint is minus 1, 6. Okay, number 33, we're going to test these different equations for symmetries. Okay, so let me look at A. We have y is equal to 2 absolute value of x minus x to the fourth. So I'm only going to demonstrate the symmetries that do exist, not the symmetries that are not valid, only the ones that exist. So this one is symmetric with respect to the y-axis. And we can see that by replacing x with minus x. And we'll get the same equation. So let's do that. So we have y is equal to 2, and here we have the absolute value of minus x minus x to the exponent 4. So that's y is equal to 2. Now the absolute value of minus x is the same as the absolute value of x, and minus x to the exponent 4 is the same as x to the 4 because this is even, this exponent is even. So we get the same equation that we had originally. So we do have symmetry with respect to the y-axis. And if you check, the other symmetries are do not exist if you do the various tests. Okay, let's look at B. B we have it written over here. Y is equal to, sorry, y minus, that's y minus x. And then we have the absolute value of x squared plus 1. All right, now this one is symmetric with respect to the origin. All right, let's replace, to see symmetry with respect to the origin, we replace x with minus x, and we replace y with minus y. So if we do that, we have minus y minus minus x square root minus x squared plus 1 equal to 0. Okay, let me just scroll a little bit. So that gives us minus y plus x. And here we have minus x squared. That's the same as x squared plus 1 equal to 0. Now we do have the same equation that we have here. If we multiply both sides by minus 1, we see we get y minus x is equal to 0 times minus 1 is still 0. So multiplying both sides by minus 1, we see we do get the original equation. So we do have symmetry with respect to the origin. Okay, let's look at C. Here at C we have xy is equal to 5. And this is also symmetric with respect to the origin. We replace x with minus x and y with minus y, and we get xy equal to 5. So that's origin. Origin symmetry. And our last equation, let's see right here. Okay, this one is symmetric with respect to the x-axis. X-axis symmetry. We test that by replacing y with minus y and see if we get the same equation back. Okay, so that would be minus y squared minus x equal to 3. which is the same as y squared minus x equal to 3. So we do have x-axis symmetry. Okay, here we have a circle in standard form. So it's easy to read off the center and radius. All right, so the center of this circle is 5. And here y squared is the same as y minus 0 squared, so that's 5 comma 0. And the radius is the square root of 7. In number 35, we have a circle that is not in standard form. Okay. And we have to put it in standard form. So let's do that. Okay, so we're going to first rearrange it, put the x terms together, and I'll put a blank next to them, and then the y terms, and put a blank there, getting ready for completing the square. We'll subtract the constant term, subtract 2 from both sides, and put 2 blanks on the right. Okay, now completing the square, we take half the middle term, that's 4, square it, we have 16. And here half the middle term is 2, square it, and we have 4. So on the right-hand side, we're going to add 16 and 4 as well. Okay, here completing the square, we have x minus 4 squared. And here factor, we have y plus 2 squared is equal to, let's add this up, and we get 18. So now the circle is in standard form, so we can just read off the center, 4 and minus 2, and the radius is the square root of 18. Number 36 is a pretty simple question. It's find the equation of the circle that has center 3 minus 5 and radius 7. So we can just write down that equation. That would be x minus 3, x subtract the x coordinate squared, plus y subtract minus 5, y minus minus 5, or y plus 5, is equal to the radius squared, 7 squared. And that's the equation. Okay, so that's our last question in the review, and good luck studying.